All right, stats students. So this is going to be a very quick lesson. I didn't get much time to record a major, huge lesson, but we're going to be talking about density curves. And on your work, the practice sheet here should be questions 1 through 7 that we're looking at. So we're going to talk about density curves. And the first thing I want to do before we write down like a definition for this is I want to look at a set of data. Okay, so I don't think that you've put this on your calculators. Maybe I sent that to you, I'm not really sure, but this is the 2018-19. So this is 2 years ago. So this is kind of older data, but it's our high school's ACT scores, okay, from 2 years ago. So we have, and I'll show it to you. If I keep scrolling, there's hundreds of students in here, and that senior class actually, if we keep going, had 527 students take the ACT. So this is by far the largest data set that we've looked at, and I don't really have much data that's bigger than this, but this is very relevant as well. ACT. A lot of you seniors just took ACT, and you'll be getting your score soon. So this is already on your mind. Okay. Now, what I want to do is I want to graph it. So if I go to this screen, you'll see, look how many dots there are. There's so many. And if you highlight individual points, it tells you the entire the different variables for each individual point in each student. So go ahead and change this to composite and then look at this. A huge amount of data. And we're going to use this to help us discuss density curves. So I'm going to go ahead and take a screenshot of this. And we are going to put it in our notes. You don't have to draw this, of course. That's just too many dots. But we're going to copy this and we're going to put it inside of these notes. And let me move that over. So here we have our distribution for composite ACT score. Now, what I would like you to do is just draw the x-axis. You don't need any of the points. And just go ahead and, you know how we've talked about you throw a blanket on top of it? That's what we want to do. So we're going to make we're going to call it it's a smooth curve for all this data. Not super smooth, mine's wrinkled quite a bit, but a smooth curve as much as you can. Let me actually go back and redo that. Oh no. I'm just going to try to make it one smooth curve. We don't want a lot of divots in it. That seems good. Okay, here we have our smooth curve, and we would call this a density curve. Okay, that's what we would describe this as. So let's go ahead and write down a definition here for a density curve. Now you'll see there's 4 things on here, but I only really care about what I've highlighted in yellow. So I'm going to go ahead and give you a second. Go ahead and write that for me. All right, so sometimes the overall pattern of a large number of observations is so regular we can describe it by a smooth curve. So honestly, if I go back and I just move this is our density curve right here. And this is what you should have in your notes. So that's our density curve. So you have your definition over there. And this is how you need to sort of be looking at data moving forward. I can put it back on here, falls underneath. There it is. So that's our density curve. Now these take on all different types of shapes, all different types. They can be skewed to the left, skewed to the right. They can be symmetric. They can be uniform. These are all shapes that we've described. But there's some key rules that we need to know for a density curve, okay? So we're going to go ahead and write those down. So we're going to write these rules. Density curves. Always above always on or above the horizontal axis. And we can see that up here. It's above the horizontal axis. Next, and pretty much the most important rule for this class, like what we're about to write is so essential that that we're going to underline it, highlight it. If you have a highlighter, you need to know this. So has an area of exactly 1 underneath it. Underline, highlight. I'm underlining it twice. You need to remember this. Every time that you look at one of these, every time you look at a density curve, you need to automatically know underneath it is an area of 1. Okay? Now we're going to say for 1 equals 100%. That's what that's coming from. Okay, so 100% of the data is underneath this. All right, and that's how your mind needs to think. So if we look at our study guide or this practice sheet here, here we have a density curve. The area underneath it is 1. Okay, down below. This is a flat line. We would call this uniform. The area underneath this is 1. If I keep going, here's a density curve. It's just a straight line. The area underneath it is 1. Okay, so we're going to be looking at all different types of density curves through this chapter, but questions 1 through 7 on here are sort of the beginning stages of density curves for us. Now there's a this is the most important rule, but there's a couple other rules that we want to write down on these. So let's talk about the mean, median of a density curve. And then give yourself some space, mean of a density curve. Okay, so we know how to find, approximate where the mean or the median would be. So up here, going back to this, let's just move this out of the way. So if I gave you a curve like this, we would want to find the mean and the median, okay? So the rule has sort of been this. Remember, for mean, it's sort of that balancing point. It's where it's going to be level, wherever that is. We actually called that the center for a while, but we're actually going to give that distinction to the mean now. It's that balancing point. And then the median is where it splits the data in half, like to 2 equal areas, we'll say. Okay, so if we have an area of 1, we want 0.5 on one side, 0.5 on the other side. A lot of times that ends up being at the peak of the data, the mode that we've called that. Let's go ahead and write down some definitions for this right here. Okay, so the median is the equal areas point, the point that divides the area under the curve in half, and then the mean is that balance point at which the curve would balance if made of solid material. One other thing that we want to write, and I'll pause this so you can write it, the median and the mean are the same for a symmetric density curve. So if you're saying that a density curve is symmetric, then the mean and the median would be the same, okay? But if we're looking at our density curve here, we could argue that this is slightly skewed to the right, okay? So we know that it's not perfectly symmetric, because look how rare it is to get these high scores. These are not outliers necessarily, but they're more extreme values that are making this skewed. So we know that the mean should be greater than the median, okay? The median is probably in this area, the mean is probably up here somewhere, which we could calculate the mean if we wanted to. I think the mean's actually still here because there's so much data, it's not moving as much. So the mean and median are here, but we know that the mean should be greater than the median if we did the statistics on this. All right, so that is that is the information for density curves. There are special types of density curves that we're going to talk about, and I'll probably have the first part of my next video going over that. But you can go ahead and start looking at the practice sheets that you have. And if you have questions, let me know. But I'm going to go ahead and stop this video here.